Welcome back, students. Now we are going to discuss the structure of polysaccharide, and in this module we are discussing the structure of the first polysaccharide, that is starch. So let's start with actually what is polysaccharide. Now polysaccharides are nothing but large numbers of monosaccharides. When they are linked together by a glycosidic bond, then you get a compound called as polysaccharides. Let's see how this is done. So in this, we would be having two monosaccharides attached via glycosidic linkages. Further, they are having a general molecular formula of C6H10O5 N times. Now, let's understand something about starch. Now, starch is an important part of our diet. It is mainly found in cereal grains, roots, tubers, corns, potatoes, etc. A couple of lists for this. Next thing, starch is a polymer made out of alpha-D-glucopyranose, and it consists of two different fractions, that is amylose and amylopectin. So now the question comes as to what is amylose and what is amylopectin. Let's understand this. Starch comprises of two things, amylose and amylopectin. What is amylose? Let's see it. It is something about 20% of the entire starch. So 80% of the starch consists of amylopectin. Further, amylose is water soluble, amylopectin is water insoluble. And the next point, the important one, it is a long unbranched polymer, whereas amylopectin is a long branched polymer. The next thing, amylose is formed by linking number of alpha-D-glucopyranose through C1 and C4 carbon glycosidic linkages, whereas amylopectin is formed by linking one or more than one glucopyranose with each other. So now, as we are knowing amylose and amylopectin, we would start with the actual structure of starch. Starch consists of amylose and amylopectin, and amylose is a polysaccharide made out of alpha-D-glucopyranose. What is alpha-D-glucopyranose? We have already learned into the previous module. So here we have the structure of alpha-D-glucopyranose. Now this structure, what we would do is, we would write it more than once. Let's see. So this is alpha-D-glucopyranose. We are writing this structure more than one time. They are attached to each other by 1,4 glycosidic linkages. So now OH from the first carbon and OH from the fourth carbon would be connected together. Let's see. So both the OHs are lost and you get a water molecule. So remaining oxygen forms a glycosidic linkage. Similar case, that is a similar glycosidic bond, would also occur between the next molecule. So let's see this. Again you have a glycosidic bond over here. Now what would happen if suppose that this molecule, that is a molecule towards the extreme right, happens to bind with the next molecule? Its first carbon OH would be lost, whereas the molecule towards our extreme left hand side, if it happens to bind with its previous molecule, its fourth carbon OH would be lost. And therefore now we can extend the chains from the first and fourth carbon positions respectively, giving us a long polysaccharide attached by alpha-D-glucopyranose chain. And thus, because it is alpha-D-glucopyranose, the linkages are now called as alpha links. And what molecule do we get? We get a molecule of amylose called as alpha-D-glucopyranose polymer. Now, amylose is done. Let's understand what is amylopectin. For this, Again we have an amylose chain wherein the first and the fourth carbon OHs are lost and the remaining oxygen forms a glycosidic bond. Again, we are extending the chain, but now remember students, we are extending the chain only from one side. Still, we have a polysaccharides. Do you agree with it? Yes. Now what we would do, let's take one more amylose chain. Again, the same thing would happen. First and fourth carbon OHs are gone. You happen to left down with one oxygen giving us two glycosidic bonds. Right now, we are extending the chain from the first and fourth carbon atom. Now comes a very, very important point, a very crucial point. Now, the first carbon OH and the sixth carbon OH combine together, lose a water molecule, thereby giving us a bond that is a glycosidic bond. But now, this bond is between two amylose chain, and therefore what we can say is that all the alpha links right now which are formed, that is all the glycosidic bonds, are used in 1,4 glycosidic bond formations and 1,6 glycosidic branch formations. So, if you happen to have a molecule in which two amylose chain get connected by C1 and C6 respectively, then they have 1,4 glycosidic bond and they have 1,6 glycosidic linkages. Then you are definitely getting a molecule called as amylopectin, which is nothing but one more constituent of starch. This was all for this module, students. Meet you in the next module. Till then, thank you.